Morning. This is Thursday, March 26th. We have a quiz tomorrow, so I highly recommend that you go through those 25 practice multiple choice questions on AP Classroom. It's titled Chapter 7 through 10, which is linear regression, and Chapter 24, which is a two-sample mean test. So I'm going to go through each one of these questions. Feel free to pause this video anytime as we go, okay? But before we jump in, I just want to congratulate our top 5 scores from last week's test. This is period 2, Class average for that class was 6.5, median 7, standard deviation 2.0. So congratulations, all you students. Okay. This was last week's test on Friday, and we'll do this again next week. And then, or the week after spring break. And then period 3, we have Enzo and Reese in the lead right there. Congratulations. Period 3's class average was higher than period 2's. We won't be doing class wars though. Congratulations, Sheridan, Malachi, Sadine, Balhan, Mike, and Paul, in no particular order for those 5 or for those 6. Okay, good job, guys. Let's keep up the good work. So here we go. Question number 1. We are talking, this is all review from linear regression. We're talking about specifically chapters 7 through 10. So pull out your textbook and follow along with us. Okay? So we're talking about correlation. Remember we used that lowercase r back in the day? R has to be between 1 and -1. Okay? So up to 1 and then -1. 1 means it's a positive association, very strong. It's linear. It's in the exact line. And then -1 would be a negative association. So when you calculate this, it's still possible that it's not linear, that a linear model is not appropriate. What do we have to look at, class, to make sure that's linear? We have to look at the residual plot. We'll come to some questions about that later. So in this case, it's possible that an exponential or quadratic model, which we haven't covered this year, and we won't, are still better. Okay, that's why the answer is E. For number 2 here, all you got to do is input this into your calculator. So you can use list 1 as your X and then list 2 as your Y. And then you calculate using 2 var stats, and then your R will appear. And this should be your value right here. Okay, so just use technology, or you can do it by hand if you would like to. We have a scatter plot here. So our X, our explanatory variable, remember X is explanatory, is the percent of woodlands. And then our Y, our response variable, is the group size of deer. Okay? So we notice that there's a negative association. You guys remember DFSU? The D is talking about direction. It's positive, linear, or neither. So we know that the answer is C because as the percent of woodland increases, we see the number of deer in the group decreases. Okay, so that's why the answer is C. Make sure you guys take a look at the answer box right here too for a better explanation or additional explanation. Question number 4 is a computer output question. For this, if you guys want to look at page, I believe it's 184. Let me just go back and double check for you. Sorry, 188, page 188, it tells you more about what these numbers mean. For this specific question, all you need are these 2 values right here. Your mass, if you read this right here, your mass, body mass is your explanatory, your X. Good way to remember explanatory and X is explanatory has the letter X in it, explanatory. Your resting metabolic rate is your Y, your response variable. So this 22.563 is your slope, right? And then to interpret your slope, it's correctly interpreted using A. You could see your sentence frame paper. Okay, this is back in chapter 7 or 8, I believe. Okay, check that out. Next question, number 5. Number 5 is asking about explanatory and response variables. So you have to know the definition of that. It's asking which is the explanatory variable. So if you read the given information, we want to predict the amount of grain from the fertilizer. So the fertilizer is what you're going to apply, what you can control. Okay, the amount of grain you can't control, you cannot control. So the fertilizer would be your explanatory. The fertilizer explains the amount of grain that you're going to get. Okay. Number 6, residual plots. You remember this from your calculator? It'd be a good idea to review how to make residual plots on your calculator as well. You cannot have a curve, right? If there's a pattern in here, no, it's not appropriate for a linear model. Okay. Number 7, I suggest you draw out a picture, draw a scatter plot. So go ahead and take a pause right now and draw out a scatter plot. You'll see that sorry guys, I'm talking a little fast. The explanatory is the number of hours that the person exercises per week, and then your y-axis, or your response, is their resting heart rate. So if you're into health and you understand this, the more you exercise, the lower your heart resting rate will be. Okay, so as one increases, the other one decreases. So automatically it tells you that the direction, the relationship is negative. So it has to be C, D, or E. Now E would be a straight line, okay, straight negative linear model. However, you know that it's not going to be that strong, right? And then this negative 0.14, that would be fairly weak, okay, really weak. So we go with D, okay? Okay, so for number 9, we're talking about large residuals and influential points and high leverage. I say, guys, go back to chapter 9, specifically page 203. Okay, chapter 9, page 203, and go over the definitions of what an influential point and high leverage is, okay? And then read this right here. Number 9 also talks about high leverage. So if you read this question over class, it'd be a really good idea to go through these questions first and then watch these videos, okay? Or pause. Maybe you want to do the question yourself, pause the video, do your question yourself, pause the video, check out your answer. So they're asking which of these points has high leverage, and you're probably, when you look at this, you're probably going to consider this one, which is answer A, or this point right here, which is answer choice D, or this point right here, which is answer E. If you go to page 204, where it talks about leverage, the definition of leverage, or having a point with high leverage, is when the x value of the point is far from x bar meaning the mean. So what would you say, what is the average, the mean of our x values? You would kind of guesstimate it to be kind of, I don't know, maybe between 30 and 40-ish. So this point right here is close to our mean of x. This point right here is far, but this point is even further. Okay, so that's why we go with answer choice E. Okay, so now that number 9 ended the questions from chapter 7 through 10. Question 10 now talks about two sample means, chapter 24. So this first question right here, it requires you to actually calculate this in your calculator. This is two sample means, so you're going to go to the stat test, and then option 4, the two sample t-test, and you're going to input this into your x sub 1 and then your x sub 2, and then you should get a p-value of 0.016. Go ahead and pause the video and try that. Now, if your p-value is 0.016, we know that it's less than your alpha. And for this case, your p-value is going to fall right here, 0.016. So that means that we do have evidence, okay, that there's a difference. And why do we know it's a difference? It's because if you read the information, we want to give different yields of tomatoes. It doesn't mean greater than or less than, it's just plain different. And you guys will notice that for most two sample mean questions, we're using not equal to in the alternative, not greater than or less than. Okay, let's see if you catch that. Number 11. Okay. So this question is just asking what type of test should you apply. This is a great question, guys, because right now, so we've gone through A, we've gone through, oh, no, A is actually not even an actual, sorry, A is an actual test, B is not an actual test, right? C we'll talk about after spring break, and D and E are, D is trying to trick you. Okay, we're trying to compare the difference in population means, not sample means. So option B is not correct automatically either, okay? But if you read this, we're comparing ash bat groups and maple bat groups. Okay, since we're comparing means, we're using a difference in population means. If we were comparing proportions, we would be using difference in proportion. Okay? Number 12. Okay, so for number 12, they give you the information and it wants you to calculate your test statistic, the T. So I'm going to go over our formula sheet. And you guys remember when we calculated z-scores, we used this formula, right? We used x minus x bar over the standard deviation or standard error. So this holds true for even t curves as well. So now our t is going to just be our x minus our x bar, our mu divided by our standard error. Now the standard error formula right here is what we have, this right here. This is what we're working on, right? For two populations, two means, we're using this. So if you go back, our x in this case is $58,000 and our mu is $55,000. And then if you input the numbers correctly, this would be our sample mean for our first group is 4,000. So our sample standard deviation. And then for our second group, it's 3,500. And then you divide by your n's. Okay? All right, so number 13 is asking you to set up your null and alternative hypotheses. So automatically you know that for the null, right, the HO, it's always going to be equal to. So all 5 of these options are equal to, which is good. Okay. Now there's something wrong with these two choices. Look at your null. Can you guys see what's wrong with the null and alternatives? We don't use x bar because x bar is talking about a sample mean, but we're talking about the population mean. Inference is all about we take samples. Guys, I'm banging my hand against the desk right now to try to make a point. I'm pointing at the computer. Can you guys feel my emphasis on this? We are taking samples and making inference about the population means. Okay? So if you read this, you see this phrase right here, higher price. It's saying something sells at higher price in the fall than in the spring. So that means fall has to be greater than spring. So we use the greater sign right here. Okay. Number 14 is asking about how you would write your conclusion. So we know that our p-value of 0.015 right here is greater than our significance level or alpha level. In that case, we do not have convincing evidence, right? We fail to reject the null and we do not have convincing evidence. Okay. Number 15 is asking for the formula for a confidence interval. So let's go back to our formula sheet. Remember, the confidence interval formula is the same for all type of inference situations. It's our statistic, right? In this case, it's the difference between our two means, our two sample means, plus or minus our critical value, times our standard error. And remember, our standard error formula is this right here, okay? So it's a difference in our two sample means plus or minus our critical value. Now notice that they don't have you calculate it. It's the same for all 5 options. And then you have to use the proper formula, and they try to trick you like this one. That's not correct right there. This one's not correct because you're not squaring your standard deviations. Okay. And then why, you may wonder, why is it not answer D? So answer D, the only difference between D and C is that they switch the order right here. But if you look at your given information, it's newer minus older. So the newer was 195, okay, and the older was 286. Okay, number 16, asking more about, do you understand what a confidence interval is? Remember, confidence interval wants to capture the difference in population means. So you may be tempted to choose B, but we're not talking about the difference in sample means. We're trying to make an interval that tells us something about the population means, because we don't know what that is. We know what the sample mean is. Okay. All right. For number 17, talking about cows eating grass, than like eating more grass than horses here. So we get a p-value of this of 0.0487 from a test statistic, a t-score of 1.664. Right? So it's asking us, what does that actually mean? What does that p-value represent? So if we have this curve here, and if we got a test statistic of 1.664, 1.664 is right here. So it's that value or above. Okay, the probability of getting a value of 1.664 or above is this p-value. Okay, so it would be answer E. It's of at least 1.664 or above. Okay, not at most. At most means would be shading on the right tail, the right side, the lower tail. Okay. Yeah, number 18, the same thing. We're comparing two means, two population means, okay? Not proportions. Proportions for option E might look tempting, but it's proportions, and we're not talking about proportions up here. There's no percentages or something out of something given. Okay. Okay. Number 19 again is testing your knowledge of the formula sheet. Right here. When you take your quiz, guys, it'd be a good idea to open up a document like this or have your formula sheet out in front of you. I know you guys only have 60 minutes for your quiz, so it'd be good to not stumble through your papers and your textbook trying to look for the formula. Number 20, same thing. Refer back to your formula sheet. Refer back to your standardized test statistic, your t-score formula. Number 21 is asking about the how you would write your conclusion. So you have a p-value here, but it's also good to recognize that what would your alternative hypothesis be here? If you read the first line right here, the average time to swim a lap with a freestyle stroke is different from butterfly stroke. So different means not equal to, okay? So when you write your second sentence in your conclusion, it should say different, okay? Not greater than, not less than, but not equal to, okay? So there is convincing evidence because you notice your p-value right here is less than your alpha, your significance level. Okay, 4 more questions. Or sorry, 4 more questions, you're right. Okay, so this one, read through the details closely again. So this time they give you your interval already. However, one thing to recognize, and this is a question that I thought I was really impressed the week before, the last week that we were actually together in our classroom. I missed that classroom, guys, that old smelly rickety classroom. Hey, did you guys notice the scent of my room after class or after my freshman? It smells completely different after my periods 4, 5, and 6 with the freshmen than it did after periods 2 and 3 with you guys. Man, I just don't know why. Pheromones? I'm not sure. Okay, so We know that this is a population mean, the difference in population means question. So if we subtract these two values right here, we know that our, I'm going to go back to this formula sheet right here. All right, this confidence intervals are statistic plus or minus our margin of error. Our margin of error is made by our critical value times our standard error. So our statistic is 7.6. I hope you can see that. So our interval is 7.6 plus or minus our margin of error is 0.5. Okay, draw that out, work that out, okay? So since our entire interval is positive, what that means is that there is evidence, right? It's likely that the southern frogs have more croaks than northern frogs because look, we did southern minus northern. Our southern croak number was 28.9 and our northern was 21.3. So when we subtract those, we get a positive value. So if you have a positive interval, that means that there's evidence that the southern is greater than the northern. Draw that out, okay? Draw the positive video and draw that out. Oh, and read this description right here too. Okay. This question is asking about, do you really understand what a confidence interval is? Class, I say you go back to for this question, go back to chapter 19, page 434 and 435, really what's on 434. But take a look at like what a confidence interval actually is, okay? You may wonder, why is the answer not B? Okay, E is the correct answer, but why not B? So the 90% is not a probability. It's just how much confidence you have in there. And what that actually means is if you constructed many intervals, okay, more and more intervals. Like if you constructed 100 of them, 90% of the time, your interval will capture the true difference, the true mean difference. Okay, so look at page 434 to 435. And the next question is very similar. Okay. See specifically page 435. There's an illustration on the bottom of page 435 which shows that. Go to page 435 right now. No, seriously, go there. I see you. You're not moving. Grab your textbook. Each of those vertical lines are intervals. And you notice that sometimes they miss. Okay? So when it misses, it does not capture the difference. That horizontal line is the actual true mean difference. Okay? And then last question. If you read the given information, they use that word difference again. Different. Oh, so whether the mean driver reaction time between the two groups of participants was different. It's not saying one is greater than, one is less than. It's just saying plain different. Okay, so that means the test is going to be two-sided, two tails. Because it's two tails here, we know that it's on the right side of the curve. It's greater than 2.763, and on the left side, if you draw a normal curve, so we're looking at this again, it's outside. What are the values again? Negative 2.763. Okay, it's like this. So p-value of 0.03. The reason why this is not 0.03 is because this is a z-curve, a normal distribution curve. But just for your illustration, it's here and below and here and above. Okay? So that's what that's talking about. All right, guys, I hope that this was helpful. Please go through these questions. Talk about it with your classmates. Let me know if you have any questions and get ready for your quiz. Your quiz tomorrow will be open at 6 a.m. and you just need to finish it by 3 p.m. It'll be 10 questions again, okay, on AP Classroom. Thanks, guys.